Hello everyone, welcome back to our new video. And in our previous video we have seen how we can use another way to test for the equality, that is by using the is function. But in our today's video we are going to see some different ways, that is how to override our variables, how to add some values. That is, if you initialize our variable and you want to add some values to it. Today we are going to see that, and we are also going to see some non-typical Python operators, like the floor division and the others. So get set for this video. So we are going to enter in our console to start with the first part, that is overwriting variables. When we talk about overwriting variables, it's like at first we initialize our variables with a value and we come and change the value of the variable. That is, we burn the previous value that was found in our variable. Let's say like we assign a value, let's say on x we assign, let me change my keyboard, on x we assign the value 1. Now if you print x is having the value 1. Now if you want to like override the value, that is change the value of x, you only need to change the value of x directly by putting x equals to 10. Now if we print x, we see that x is equals to 10. So that is how we can override or change or burn the value of x of any variable, which is known as overriding variables. Now what if we want to assign values to different variables? Like you are having 3 variables, let's say x, y, z, and you want to assign some values to them. How are we going to do? So it's pretty easy. We are going to do, like, let's say x will take a value 1, y will take the value 2, and z, the third variable, will take the value 3. Now if you print the value of x, you see that x is 1, y is 2, and z, you see that z is 3. Now this method is very fine, but however Python is having another way that is very economic, that will help us to save space. The Python method will help us to save space. Let's say we want to assign the same values, that is x equals to 1, y equals to 2, and z equals to 3. The simplest way, which will be economic, which will save memory, will be like we write x, comma, y, comma, and z, and now we assign to these 3 variables different variable by separating them with commas. One will be for x, 2 will be for y, and 3 will be for z. Now if you want to see if our value is corresponding, like let's say z, we know that z is equals to 3, so let's print z and see z. So here z is 3, y is 2, and x is 2. So here we have seen that Python has given us a very easier way that is more economical in order to declare our variables. Now the second issue that we are going to see is like if you have initialized our variable and we want to add some values to our variable. That is, let's say our variable x is having the value let's say x is having the value 1000. Now we want to add like 100 to the 1000 we are having. Here x is having the value 1000, and if you want to add x, the logical way to add is like we use x is equals to x plus, let's say we add 100 to our 1000. So now if you print x, like this one is a simple statement equation, it's a simple expression. That is in our previous x, because you have seen how to override variables. Now here we are overwriting our variable by taking the initial value and adding another value to it. And here you see that x is equals to x plus 1000. So the first x, before we override the x, you will first see x, which is 1000, and now when you add 100, it will be 1100, and now the 1100 will override or we burn the 1000 that was found inside the variable. Now so if you print, it will be 1100. So here is 1100. But this one is a very logical way to show our to add some values, but we are having a more Pythonic. That is, Python gives us an important or interesting way in order to add values to our variables, which is the augmented variable. That is, we use x and we put a plus sign and an equal sign, and we add 100. Now here is a very simple way, economical too. We reduce our line of code, our code become more shorter. So this is the simplest way that Python gives us in order to add values. So here, if we try to see our result will be the same thing, that is 1100. And here if you print x will be equals to, I forgot to overwrite. So our x was 1000. So here there's no even problem, but x x is 1100. So if you add 100 on 1100, it will be 1200. So let's see, let me change override x is equals to 1000, and now we do x, we use our economical way, x plus equal, and we add 100. So now if you print x, here x is 1100. So this is our result. So we see that it's very economical, it does not take more space, less shorter code, so it's very important. Now this way of adding values is the same thing with the similar operators, that is the subtraction, the multiplication, and the division. Now let's say we are having let's try with the multiplication. That is, we write x is equals to, let's say, 10, and now we want to multiply, we want to change, that is, add something on our x as previous. So here we are using the multiplication operator. So you use the more economical way, that is, we write x and the multiplication sign and an equal sign, and we add, let's say, 10 times 2. So here the result will be 20, which is very economical. And let's also try with the division operator. We use the same thing, x equals to, let's say, 10, and now we want to divide, we want to reduce, like divide or add something to our variable. So here, so you use the division sign, which is here, and we add our equal sign as previous, and we add the value we want to divide. So x is 10, we want to divide by 2, so you add 2, and now if you print x, you are having 5.0. so here it converted our you have seen one change there. It converted our integer into a float. So, and it works the same thing in subtraction, that is x equals to 100, and now we want to subtract something. You have to subtract something from our 100. You do x minus equal sign, and let's say you subtract 20. So if you print x, the answer will be 80, which is very correct. So which is also cool. This is the interesting part of programming. Now the last part of our video will be on non-typical operators that we can use in Python. And the first non-typical operator that we can use here is the modulus, which returns the remainder of an integer division. Here, let's say we divide 2 by 10, and we know that 2 divided by 10 is 0.2, and as we have done since in primary school, we know that if you divide any value by 10, you take it will be like 0.2. so it depends on the value. Now the remainder here is 2, because when you divide 2 by 10, the remainder is 2. Now how can we get the remainder? That is here what Python gives us as the modulus, which get the remainder of an integer division. Let's do it on the console, like x equals to 2, as we said. Now y equals to 10. Now if we try to do the division, like x divided by y, and we put in here, you are having x on y will be 0.2. and now if you want to have the remainder of our division, which is an integer division, you will do x modulo, which is the percentage. The mod is the percentage, the modulo sign is a percentage, so x mod y. So here you have clearly seen that our remainder is 2. So this is one non-typical operators that Python offers to us. And now the second non-typical operator we are having here is to perform the exponential of two values. Let's say x, we use x equals to 5, and y equals to, let's say, 2. Now if you want to take 5 to the power 2, you do x, and now to raise something to the power in Python, you are using 2 stars, that is 2 stars, and it will be here, it will be you can read this as x raised to the power y, which is x is 5 and y is 2, so 5 raised to the power 2. Here the result will be 25, that is 5 times 5, which is 5 squared. So we have seen that our result is 2. We can try also with another example. X equals to, let's say, 2, y equals to 10. Now if you try, it's the same thing. We can do vice versa. We can change, we can use y before or x before. It depends on what you want to do. There is no order of variable that matters. So x to the power, let's say, y to the power x, which is 10 to the power 2. So our answer is 100. There is no error. So these are some basic non-typical operators that Python can give us, that Python gives us instead. I'm sorry. Now the the last non-typical operator that we can use here is the floor division, which was used in Python 2. For those who have already used in Python 2, so the floor division operator was used as the division operator in Python 2. Now, that is, if we say x is equals to, we use x is equals to 10, x equals to 10, and y equals to, let's say, 5. Now, if we perform the floor division here, it will directly give us the integer part. So if you perform the normal division, let's say the normal division first. Here, the normal division, x on y, the value is 2.0. Now if you perform the floor division, x, and the floor division is denoted as the double anti-slash y. So here our floor division is 2. So here what it does is it changes our normal division into an integer. So no matter the value, it will take the integer part. So that is all about the floor division. Now, given all these non-typical operators, what if we want to use the same augmented method that we have done let's say previously here? Like here, we were using this simple method to perform on our operation. So this method can also be applied on these operators. Let's take an example with the modulo operator. That is x is equals to 2, x equal to 2. Now y, let's say y equal 10. I like this example. Now x modulo, we can use, previously we were doing as such. We were instead like previously, let's come here. Okay, previously we were dividing. Instead we were doing x divided, or we were doing x divided by y, and the answer was this, and we take x modulo y, which is 2. Now we can use the simple augmented method, that is, we use x and we apply directly the modulus, the modulo operator here, we call y. So if you print x now, you see that x is equals to 2, which is the same thing on our exponential operator, which is let's say y equals 10, x equal 2. Now we can do, previously we were doing like y double star x, which is 100. Now we can do the same thing here, like y double star is equals to x. So here if you print y, you are having the same 100. So this one are the simplest way that we can do, and it applies the same thing on our floor division. So in summary, this video has shown us how we can perform some various operations on Python data types, which are more economical, which reduces our code, the length of our code, which bring our code to be more visible. Thanks, and see you in the next video. And in the next video, we are going to see another important factor of Python. See you. Don't forget to subscribe and like.